Here's 59 practical ways construction contractors can use AI and automation to boost revenue and reduce cost. I want to talk about use cases from contract administration to procurement to scheduling and estimating. Now, importantly, I don't want to bore you to death with some massive list of use cases, some of which may or may not apply. I want to talk at the beginning in principle about what AI is fundamentally good at, what it's bad at, and where it makes sense to use and apply in construction so you can take these applications and tailor them to your own projects and business. I'll also put a link in the video description to this list of use cases that you can download. Okay, so the way the list is structured is it's broken down into categories. So we've got estimating, contracts management, design management, admin, quality, scheduling, procurement, reporting, document generation, and learning. And then we've got what the use case is, the type, whether it's artificial intelligence, so using something like Claude or ChatGPT, or whether it's an automation, so using a tool like Zapier or N8N to automate a workflow. Then we've got the simple application of this. For example, if you want to create a tender summary, you can just prompt Claude and upload the tender documents. The advanced or more sophisticated version would be using Operum, which is my AI estimating software, which I have to shamelessly promote. And then a bit of a description of how to use it and how to apply it. This is a list I've been working on for a while. Some of these use cases I've done videos for. Some of them are things I'm working on in my consulting business. Others are just ideas I have that I want to try. But again, keeping up to date with this, and I'm going to try and keep this a live document that I keep updated, is important because there's so many different tools coming in. Like for example, I'm patiently waiting for the Bluebeam MCP, which is meant to come out, or the Claude co-work feature, which everyone's talking about now, which hasn't been released on Windows. But as new tech comes out, I'll try to constantly keep this updated and relevant with what I find and what I find useful. If there are things missing or you think there's other cool use cases you found, I would also love to hear about them. If you want to comment or send me a message. Before we jump into going through the list, I want to just talk about how to think through these use cases and what AI is good and bad at and what it suits certain construction tasks and where it doesn't suit it. So the way I think about AI is AI should basically reduce the chance of something go wrong. It's not something that you can push responsibility to it. So if you think about an example of that, then I think it makes sense to check your estimates to reduce the chance you're underquoting. But the idea that you rely on AI and give responsibility to it to prepare an estimate for you just doesn't make sense. That's why I think if a lot of people, when they fail using AI, it more comes down to how and when it's applied, not necessarily the capabilities of the model. We all know the problem is you get output from AI, looks clean, structured, and confident, but it's also quite often wrong. It'll imagine, say, for example, you're asking it to, I don't know, review your tender documents. It might completely miss things, and it's in these omissions and confidence with which it answers that is where you get these really painful failure modes. It's all about, this is true that this is a failure mode of AI, but I don't think that is a reason not to use it. You just have to be strategic about how and when you apply it and understanding the failure modes. So why does AI fail at construction tasks? Well, the big one, which everyone's kind of aware of, but I think it's poorly explained, is that fundamentally AI doesn't know what you know. The problem with this is it misses context. So yes, you can upload your project documents, your drawing and specifications, but obviously AI can't walk around a construction site and see things. It can't have conversations, doesn't have access to all your messages, conversations, chats you have with people, stuff you've seen, doesn't have institutional memory. So if, for example, 5 years ago, you ran into a problem with a certain type of in-situ wall because of certain type of product used, it just can't possibly know this. So if you think about, in the perfect world, if it had the right information, had access to all this context, it would produce much better outputs. But I don't see until everything's done by robots, until it's just machines interacting with machines building stuff, I don't see how this problem is actually solvable. There's always going to be this missing context problem. The second failure mode to understand, which isn't a failure in the models, it's a feature of the models, but it leads to failures in construction, is the idea of stochastic output. So artificial models by design are probabilistic. You give the same model, the same context, the same prompt, every time it will give you a slightly different answer. That's because these models are stochastic. They follow probability distribution. So one input the output of that is a distribution of possible answers. What this leads to is if you have long, complex tasks, because you've got this variability in each stage of the output, that as tasks get more and more complex, you increase the chances of hallucinations and mistakes. Because you have this compounding effect where you have one little deviation, another little deviation, another little deviation. By the time you get this long, complex task complete, the answer you've got is completely different to what you wanted. Humans, they obviously do struggle with this a bit, but we have this common sense feedback loop where we can look at something and it can just feel wrong to us. AI fundamentally doesn't think and reason, so it can't pick up errors like this. So it can be confident and give these well-presented answers that just absolute gibberish, and the actual reasoning behind them makes no sense. So we have to be aware of this randomness aspect. So consequences of this, based on these failure modes, is we can have hallucinations where it just gets stuff completely wrong that would be intuitively wrong to us, but it doesn't understand. And that's a function of missing input context and also randomness. False completeness, which is probably, in my opinion, the worst problem that we deal with, because the way we check AI's work, it's actually quite hard to pick up on this false completeness issue. And I'll talk about this in a section. It gives you confident wrong answers. Again, that is a problem because it comes across so confident, you just be completely wrong. And then the bad commercial advice, this is to do with the fact that because it doesn't really understand the incentive. So by and large, if you're reviewing a contract, you understand that there's money on the line. AI doesn't feel this. It doesn't have this same sentiment of the risk associated with decisions. So most of these failure modes I gave were relatively generic across industries, but I want to talk about why specifically construction is hard to implement AI into and these specific challenges we face. So first one are these long feedback loops. If you're using AI to write code, the code either compiles or it doesn't. It's immediately obvious the error you've encountered. If you're using AI to design a marketing campaign, you put some money on Facebook ads, you'll get feedback in 24 to 48 hours whether it's working effectively. Areas in construction are much harder to actually identify and pick up. There's no quick checks. Well, there are quick checks we can do, but there's no quick outcome verification. So for example, you use AI to write an inspection and test plan. You'll find out that inspection and test plan is wrong when you're doing the work and encounter a defect that should have been picked up in your pre-pour inspection. These sorts of errors are much harder to pick up because there's very long feedback loops. The second thing that makes AI particularly tough in construction are these high consequence decisions. Again, use the example of using AI to write code. You get incorrect code, your landing page or your website might look slightly odd or the font's wrong. With construction, if you're using AI to review a contract or prepare an estimate, if the estimate's wrong, you're going to lose money on the project. If you're using AI to write a safe work method statement and someone gets hurt, that is a real world consequence. These are huge consequences we make when making decisions as construction managers. So even small variabilities in the outputs or inaccuracies can lead to massive problems. And the final one is construction projects. You probably don't think about them like this, but they actually have very complex distributed context with which we use to make information. Again, using coding, you've got your code base and there's certain rules about using the software or the syntax of writing the software in the language. We're talking about context in construction. We're talking about conversations between people, phone calls with subcontractors, WhatsApp messages, drawings, project specifications, RFIs, addendums, site visits, what you see when you're actually completing inspection. There's all these different forms of information that feed into our decisions. So if we really take a step back and think about AI use cases in construction, we're always going to come up against these three obstacles: that we've got very long feedback loops, which makes it hard to pick up errors. We've got high consequence decisions, and we've got complex distributed context. So to really get anything meaningful out of AI, it's hard to give it all the correct input information. So when I'm designing use cases for AI or testing use cases for AI in construction, these are the rules I like to follow. Rule number one is you have grounded answers. So factual responses to questions. So because AI is often going to lack context around task, as much as possible, you don't want the AI to infer or guess things. You want it to answer based on factual responses. You want answers that are anchored in documents and data. So good examples of this would be asking AI what the clause in the contract says, listing all the notice requirements, extracting the scope, inclusions, and exclusions. It's answering based on the reference documentation. Bad examples would be judgment calls, where you're asking, is this risk acceptable? Is this a good estimate? Would you accept these terms? Judgment calls are just not what AI is good for. Rule number 2 is you need easy verification of outputs. When you're using AI, you have to assume that quite often it'll be incorrect or at a minimum inaccurate. So where you can quickly verify the output of AI, it works relatively well. So this would be extracting a clause from a contract, comparing two different quotes, error checking of an estimate. It'll give you suggestions and then you can quickly verify the source truth of this suggestion. We're talking about bad use cases of AI. These are long horizon, complex tasks where you're not in the loop of how the workings happen. So for example, you're getting a full AI generated bill of quantities. Some of the AI software quantity takeoffs tools actually do this pretty well because they show on the drawings as they're going how they're extracting quantities. But if you're just using an LLM like Claude or ChatGPT and you're not getting visibility into the workings, with these long horizon tasks, you can quite often get significant deviations and not really be able to trace back why that's happened. So this would be any sort of complex task like scheduling or preparing an estimate. And if you actually have to trace all the workings and it's not immediately visible why it's made certain decisions, often verifying the output will be harder than just doing it yourself from first principles. Then my rule number 3 is you want it to be making decisions with limited downside to output sensitivity. What this means is while AI might necessarily be completely wrong or might not make a huge hallucinations, you will get variability in the output. So anything where it's doing critical stuff where small output variations from the AI result in huge downside, they're just use cases you want to avoid. So for example, if you're using AI as a first pass to compile and categorize client correspondence, to update your document and drawing registers, these are use cases that generally don't have significant downsides if there's mistakes or errors. But if you're using AI to prepare your primary costs for an estimate, you're relying on the AI to accurately produce the critical path, to make contractual commitments, these are just bad use cases because if it gets it slightly wrong, it can have big consequences for you. If I use the example of using AI for quantity takeoffs, if you're using AI to measure the primary cost driver of your project, for example, you're a concreting contractor, you're using AI to extract all the concrete quantities, which is the main driver of your price, I would say this is a terrible use case of AI. However, if you have a database with your ratios of consumables to concrete or whatever, and you're just using AI to take the key quantities you've measured to do the final 10% of the quantities, that I say would be a good use of AI. Okay, so let me start to go through this list and talk about where I think AI makes sense to use under each of these different categories. So for example, estimating, the first good use case you have is to take the client's tender documents and turn them into a structured summary. So this was one of the use cases I built Opera around, where you upload all the client documents and you turn it into a structured overview of the project with inclusions, exclusions, take out the bill of quantities, gives you a summary of key contract terms and other items. Again, very simple, very quick. You upload the project documents and it gives you a structured summary so you can quickly work out what the project's about. Worst case, the AI gets it wrong. You miss something. To prepare the estimate, you would still go through and do this yourself. So you're just using it to streamline the process a little bit. Another good use case of AI, I think, is checking your estimates for errors. You can upload the project documents, turn them into a requirements register, then compare this against your actual estimate to see if you've missed anything. You would still check your estimate anyway. You're still doing the estimate yourself. All you're getting is a second set of eyes on it, which is the same principle, I think, with cross-checking your quantities rather than relying on AI to do a quantity takeoff. The next one would be if you're tracking all your assumptions, qualifications, and exclusions as you're preparing the estimate. So you're doing this yourself. You then take that set of exclusions and you get AI to reformat it into a letter of offer. Basically just using AI to polish your work rather than doing it all yourself from first principles. The next one would be if you have a whole lot of subcontractor quotes, using AI to pass and extract these and input them into your resource library in whatever estimating software you're using. Again, you can use specific tools like LlamaPass that are designed to use AI to extract relevant information, but it's just saving you time. And as you're preparing the estimate, you can cross-check some of these and you should flag if any of them look completely wrong. The next one are subcontractor quote comparisons. Quite often, if you're a general contractor and you have 20 or 30 subcontractors, you wouldn't have time to go through and do all the inclusions and exclusions on every package yourself. Again, It's just text processing. AI can do a very good job at this. The final one would be with your own rate database. So your own rates from all different projects, parametric rates like rate per meter cubed of concrete supply and install, or cost per linear meter of trenching. You can benchmark the rates in your estimate by using AI to compare this to a database you have from all your projects. So you're not using AI to generate everything, you're just using it to compare and flag outliers. So if I show you a simple use case of using AI for estimating, I uploaded a copy of my construction estimate in Excel. Then I asked it to review and check the estimate against the tender documents to compare and identify any gaps and errors. And it output a structured set of gaps from my estimate that I should potentially look at. Now, something I found when you're using AI for tasks like this, even if there are no errors in your estimate, it will find them. By default, if you ask it a question, it will generally give you an answer. It has a bias towards telling you something's wrong if you ask it, is there something wrong? But still, it's a good just cross-check or second set of eyes to go through your estimate. Next, when we talk about contract management, I think AI has some really good applications here for sort of two primary reasons. Number one is a lot of contract reviews and negotiation are just a big comparison exercise where we're taking standard clauses we accept or we would be happy to sign a contract with, and we're comparing them to what's in a client's contract. We're not really relying on reasoning. It's just a big pattern matching exercise. Second thing is contract management is something that bigger contractors tend to do really well because they have the resources to pay people to do it. When smaller contractors just don't do it well because they don't have the same overheads or money that they can put into contract managers and contract admin. So even if AI wouldn't be as good as a full-time contracts admin, you can get it to do a lot of the heavy lifting that you know you should be doing but otherwise wouldn't do it. For example, you could upload a copy of the contract that your client sends you and ask it to compare against your library of standard terms and conditions and to flag any deviations. For example, if you only accept liquidated damages with a 10% cap, it would flag whether there is a cap in the contract for liquidated damages. Or for example, if you never accept consequential loss, it would look for the consequential loss clause in the contract and identify if there's a deviation there. Some other use cases I have experienced with AI is you could create a notice requirements register. So basically you set up an automation where every time you get a new email to a project email address, it tracks that, it determines whether there's grounds for variation and then whether you should provide notice. You can actually get it to help you draft variations. You can use it to then stress test variations. For example, if you've prepared a price for a variation, you can then submit your justification to AI, tell it to act as the contract to pull it apart. So you do the negotiation with AI and prepare a bulletproof price before you actually take it to your client. You can use it to help draft payment claims against your progress and work complete, or prepare an extension of time using the same principles. The next category of use cases are for design and documentation management. Again, I think AI is actually very good for this because the use case I've been experimenting with a lot is setting up an automated project email address using Airtable. Yeah, this is an example of an automated RFI register where you set up a project email address. Every email gets stored into a database like this. It looks for correspondence about RFIs and then creates an auto-updating RFI register so you can track any design issues and the closeout of them. You could make this a little bit more complex where you actually have the attachments to the email auto-saved in a folder. When you get new revisions of a drawing, you could actually use these to extract the drawing number and the revision and get it to update your document register. If you get an RFI, you could then get it to do some sort of cost impact assessment, all these sorts of things. Okay, so the next category of use cases would just be general site administration. And I've already spoken about the project email address setup, the correspondence register, RFIs, the same sort of thing. The really good use case I think as well is almost everything like Google Meetings, Zoom now let you do AI meeting minutes. Meeting minutes, just one of those things we know we should be doing, but we often don't do. So getting AI to do that for you will just save you time. Well, not even just save you time, but get you to do something valuable to help you track correspondence with your client. The other one I think is really good is you can set up a very simple site diary that captures the exact information you want. So this is an example I did an Airtable where for each day you're just tracking some basic information like the projects we're working on, the supervisor, the weather, who did what hours they worked, what different tasks they worked on. it is a simple form called it goes into a simple form called a daily site report that you can just fill out each day for your project, track all the people worked on the project, the hours they worked on. I mean, you can chop and change it. You could just do a report of what each subcontractor wants done, and then you can turn it into a simple dashboard, which gives you things like performance against cost codes. Now, there's not really any AI in this. This is just a simple automation, but you could build something like this in Airtable in a couple of hours. Another cool use I want to experiment with is actually using AI to track all the photos you take on a project and turn this into a searchable register. I'm not sure about you, but quite often on my phone on a project, I'll get hundreds and hundreds of photos. Something I want to experiment with, I haven't done it yet, is whether you can use a simple AI pass to tag what the photo relates to and turn it into a searchable database. So tools like Airtable let you store photos in a database, and you could use one of these AI fields to just do a first pass of the photo and categorize what it is, what structure it relates to, the date it was taken, this sort of stuff. But that is theory. I haven't done it yet. So quality, again, I would see the use case of quality. You could use it to help you generate inspection and test plans. So you take the project requirements plus some templates and examples you have, and you just get them to do a first draft based on your project. Could use it to help track defects and provide defect notices to your subcontracts. And you could also use automation tools like Airtable in the same way we did the site diary form. You could have your inspection checklist on a simple form like that and log the completion. The next set of use cases relate to scheduling. Again, scheduling I actually think is often a better use case than estimating, because estimating you've got a lot more money on the line. Scheduling as a discipline is probably a little bit simpler because there's less at stake. And it's also, something that contractors often don't do a good job at because they have to prepare an estimate, but obviously they're too rushed to prepare decent schedules. So in that sense, you can use AI to help you prepare Gantt charts. For example, you could upload your construction estimate, which probably has most of the data in it that you need to prepare a good schedule, get it to turn it into a Gantt chart. You could help it review your subcontractor schedules, you could update your progress, so capture your progress in a work breakdown structure, percentage complete for each task, and each week just upload that into AI and get it to update your baseline schedule. You can help it to support extension of times claims by developing a schedule which has all the client milestones on the critical path. You could upload that, explain what's changed, why a delay exists, and get AI to help you use AI to help you prepare an extension of time. I mean, the simplest use case to experiment with is to actually use AI to prepare a schedule though. So Claude can run Python code within it, so it can actually create these custom user interfaces for you. So here, based on the estimate I've uploaded, I've actually asked it to prepare an interactive Gantt chart. And here's the result. So it's given us this, basically taken our estimate, so all the scope in our estimate, and it's turned it into a full project schedule. So I obviously haven't reviewed this. I haven't really played around with it too much, but you could go through and update the tasks, do a detailed review, basically refine it so it captures your own information. Again, if you have your own library with productivity rates, maybe activity sequences and tasks from other projects, you have a template for how you want your schedules created, you could get this much more customized and improved. Now, in the same way we can create a custom user interface for our Gantt chart, we can also create a custom user interface for any project reports we want. At the end of the day, a project report is just a source set of data like your cost reports, your work breakdown structure with all your tasks, the quantity complete, the quantity remaining, and some custom user interface around it. So using the same process we did to create the Gantt chart, you could also do a custom project dashboard where every week you either link your project data to Airtable using MCP, which is just a fancy way of linking AI tools, or you could just export the data or upload your Excel cost reports and turn it into a dashboard to basically save you time. You can also take this a step further where you actually get AI to do some sort of trend analysis and look at issues you're facing and potential flags. Something I really want to experiment with here is trying to compare your actual progress report and project data and your email inbox, if you're tracking all your email correspondence, to potentially flag issues such as documents not approved or other potential delays to the project. Then the most obvious use case, which we're probably all aware of, is you can actually use AI to prepare documents. The caveat I would say here is you want to use something like Claude Skills, which allows you to take a series of templates you've done, turn this into some repeatable process, some specific structure the way you want your inspection and test plans, project reports, safe work method statements, the way you want your actual documents prepared. Use that as the baseline. So every time you're asking it to prepare a swims for the project, QA check sheet, whatever, it's going back to your previous examples and templates and reformatting it in your own style. So that is the power of using something like Claude Skills to do that, where you're not relying on the AI coming up with the format and then producing the document. You're telling it exactly what you want. You're giving it an example, and then it is creating the document. And then the final use case I would say is just to learn new concepts, understand, or even get up to speed with the project scope. Google have a tool called Notebook LM. It's completely free to use. It's actually designed for university students studying, but it's what's referred to as a RAG system, which stands for Retrieval Augmented Generation. So instead of getting AI to answer generically, you upload your documents and it always answers with citations against your specific document. So you know it's not hallucinating, making stuff up. You could upload all the project specs, the contract, the drawings, ask it specific questions, and it will answer specifically with clauses and references to the documentation. If something's not in the documentation, it won't respond. But you don't just have to use this on project documents. So you want to understand electrical engineering better, or concrete better, find good high quality resources and use Notebook LM to turn them into things like flashcards, mind maps, quizzes, whatever. So this list, it's not exhaustive, but I think the principles to which you can apply AI to construction and some creativity, you can come up with a lot more use cases that hopefully help you increase your revenue and decrease your costs.